Hi guys, welcome back to Industry 360 and today's topic is hyperparameter tuning. It is a very interesting topic because in this video you will learn what is hyperparameter tuning, what are the techniques of hyperparameter tuning, and I will also tell you the difference between the techniques of hyperparameter tuning. So let's connect you to PhD Analytics. I hope you enjoyed this video. Let's begin. So first we will try to understand what is hyperparameter optimization. Hyperparameter tuning, model selection. As you can see, you are creating your model on your features and it is giving you a model performance of uh, around 90% and you want to increase your performance. So what will you do? You will change your hyperparameters, and according to the hyperparameters your accuracy of model will change. So that is hyperparameter optimization. So in this hyperparameter optimization, you have to find the best values for the hyperparameters of your model. So in some values of hyperparameters, your model will perform less, and in some hyperparameters values, your model will perform very good. So you have to find that good hyperparameter values. These are two tuning algorithms which are basically used in machine learning. The first is grid search and the second is random search. In the grid search, it is a technique which tends to find the right set of hyperparameters for the particular model. Hyperparameters are not the model parameters and it is not possible to find the best set from the training data. Model parameters are learned during training when we optimize a loss function using something like a gradient descent. In this tuning technique, we simply build a model for very combining combinations of every hyperparameters and evaluate each model. The model which gives the highest accuracy wins, as I told you before in my previous slide. The pattern followed here in the grid search CV is similar to the grid, where all the values are placed in the form of a matrix. Each set of parameters is taken into consideration and the accuracy is noted. Once all the combinations are evaluated, the model with the set of parameters which give the top accuracy is considered to be the best. The second is random search CV. Random search is a technique where random combinations of the parameters are used to find the best solution for the build model. It is similar to the grid search and yet it has proven to yield better results comparatively. The drawback of random search is that it yields high variance during computing. Since the selection of parameters is completely random and since no intelligence is used to sample these combinations, luck plays its part. As you can see in this video, the first figure is of grid search CV, in which you can see that the dots are connected in the grid form. One of the drawbacks of grid search is that when it comes to dimensionality, it suffers when evaluating the number of hyperparameters grows exponentially. However, there is no guarantee that the search will provide the perfect solution, as it usually finds one by aliasing around the right set. The second figure is random search CV. As random values are selected at each instance, it is highly likely that the whole of action space has been reached because of the randomness, which takes a huge amount of time to cover every aspect of the combinations during grid search. This works best under the assumptions that not all hyperparameters are equally important. In this search pattern, random combinations of parameters are considered in every iteration. The chance of finding the optimal parameter are comparatively higher in random search because of the random search pattern that the model might end up being trained on the optimized parameter without any aliasing. As you can see, in the first row and in the first column you can see we have hyperparameters. In the second row we are having parameters and in the third column we have score. So as you can see in the first column we are using n layers equals to 3, n equals 512 and learning rate equals to 0.1. and we are doing weights optimization. As you can see, our accuracy score is 85%. Similarly, in the second row, you can see after doing the weight optimization, we are getting 80% of accuracy score. And now see the last row, in which we are using n layers equals to 5, n neurons equals to 256, and learning rate equals to 0.1, where after doing the weight optimization, we are getting 92% accuracy. So we have improved our accuracy score using hyperparameter tuning. And now our model will predict good and accurate results. That is why we use hyperparameter tuning. Thank you guys. I hope you enjoyed this video. Stay connected to Industry 360. Thank you.